Hello and welcome back. So our last example for volume between, to find the volume between two surfaces, we're going to look at the region bounded by the following paraboloid and above by this sphere. So I'm going to kind of graph this out the best that I can. So these are both centered at the center. So if we look at the first one, it's a paraboloid. This is going to be parallel to the XY plane. Each of the surface cuts are going to be parallel to the XY plane. So the paraboloid is going to be opening up on the Z. So it's going to look kind of like this. And it's going to go around and around and around like that, like so. Now next, we're going to be bounded by the sphere, which has a radius of √6, right here. And well, what that does for us, well, that's going to kind of go over this. It's going to like you have this like a ice cream cone type of deal going on right here. So it's going to cut it and make this a circle right up here. So here we have our sphere on top, and on bottom we have our paraboloid right there. And the first thing we do to get the volume, the change in z's is going to be easy. So let's go talk about the limits here. We can go and start with the limits. I can go ahead and get my change in z. Because my change in z is going to be, well, I'm going to look for the bottom of my paraboloid and on top to my sphere right there. So my bottom is going to be the paraboloid. And it's already in terms of z, so it's going to be x squared plus y squared. The top, whoop, I have to solve here. Z would equal the square root of 6 minus x squared minus y squared. And I can go and write that down. 6 minus x squared minus y squared. And when we start talking about more with polars, boy, this is going to be much easier to integrate. But now we have to talk about the base limits. Now the base, again, I'm going to use the x and y plane. And to get the base, I have to look at the projection of the intersection. So we want to get the projection of the intersection. And we can get that pretty easily. Just basically, since they're both equal to z right here, I can just solve this. But there's another way we can do it right here. See, I know that z equals x squared plus y squared, but I know that x squared plus y squared plus z squared equals 6. So take a look right here. This x squared plus y squared, well, what could I replace that with? I can replace that with z. So I could say this. Z plus z squared equals 6, or z squared plus z minus 6 equals 0. And if I factor that, we would get z minus, or z minus, 2, and z plus 3 equals 0, and we would get z equals 2, and of course z equals negative 3. But the problem is, remember, this is a paraboloid. It's going to intersect, it's going to go around again. So this is extraneous because we want z to be positive. So that's an extraneous solution there. So we don't worry about that one. We only want z to be 2 because we only want the upper half of the paraboloid. So it's going to intersect, so z is going to be 2 where they meet. So the equation of my base then, well, z is just 2. I can now write this as x squared plus y squared equals 2. And I just got that from my paraboloid. So there's my base. So my base, if you notice, is a circle. And if I look at that circle right over here, and now I can get the rest of my limits. The top of the circle is the square root of 2 minus x squared, and the bottom of my circle is negative square root of 2 minus x squared. So my change in y, since I did do vertical, my change in y's would be negative root 2 minus x squared to positive root 2 minus x squared. And my change in x's, that's going to go, so this is going to be moving from left to right, goes from negative root 2 to positive root 2 because my radius of my circle. Negative root 2 to positive root 2. So, oh boy, that's a lot of writing. So now we can go ahead and get our volume. it's our triple integral, dv, then my base, dy, dx. So dv, we said, is going to go from x squared plus y squared to the square root of 6 minus x squared minus y squared. My change in y's go from negative root 2 minus x squared to positive square root of 2 minus x squared. And my change in x's are going to go from negative root 2 to positive root 2. And that will give you the volume of the region between the sphere and the paraboloid. Alright, so I hope you enjoyed the video. If not, don't let me know. Smash that like button. I'll see you later. Bye-bye.